Grain is being added to a silo. At time t equals 0, the silo is empty. The rate at which grain is being added is modeled by the differentiable function g, where g of t is measured in cubic feet per minute for 0 is less than or equal to t, less than or equal to 8 minutes. Selected values of g of t are given in the table above. A. Using the data in the table, approximate g prime of 3. Using correct units, interpret the meaning of g prime of 3 in the context of the problem. Since the table shows the amount of grain in cubic feet per minute at time t equals 1 and at time t equals 5, we find that g prime of 3 can be found by using the mean value theorem on the interval 1, 5 to find the slope between these points. In order to find g prime of 3, we need to use the mean value theorem, which states that we need g of 5 minus g of 1 over 5 minus 1. G of 5, according to our table, is 20.5 minus g of 1, which is 15.1 over 4. This is equal to 1.35. G of t is measured in cubic feet per minute, and g prime of t is g of t's rate of change with respect to time t. This means that g prime of t would be equal to cubic feet per minute over minute, which is equal to cubic feet over minute squared. This means that g prime of 3 would be equal to 1.35 cubic feet over minute squared. In other words, 3 minutes after the silo starts to fill up, the change in the rate of change of grain would be 1.35 feet cubed per minute squared.
Write an integral expression that represents the total amount of grain added to the silo from time 0 to time 8. Use a Riemann sum with 4 subintervals indicated by the data in the table to approximate the integral. To create a Riemann sum, we're going to start by setting up an integral to find the volume of the accumulation of the time from time 0 to time 8. So that's our interval of g of t dt. To set up the Riemann sum, v is going to be approximately, because it's not an accurate number, 15.1 because it is the second value. Since we're doing a right Riemann sum, we're not using the first value because it's a left value, times 1 because it is the interval of 0 and 1, which is the width. So the next value is gonna be 20.5 because it is the second value of g of t, and then 5 minus 1, the interval 4, plus 18.3 times 1 because 6 minus 5 is 1, plus 22.7 times 8 minus 6 is 2, so times 2. And that is gonna be equal to 160.88 feet cubed, or cubic feet.
The grain in the silo is spoiling at a rate modeled by W of t equals 32 times the square root of sine of pi t over 74, where W of t is measured in cubic feet per minute for 0 to 8 minutes. Using the result from part B, approximate the amount of unspoiled grain remaining in the silo at time t8. Part C is asking for the volume of unspoiled grain. In order to get the volume of unspoiled grain, we need to subtract the total value, or the volume of the grain, minus the volume of spoiled grain. The volume of spoiled grain is given by the integral from time 0 to 8 of Wt. So now we plug in the volume, the answer we got in part B. This is equal to 160.8 minus the integral of 0 from time 0 to 8 of 32 times square root of sine of pi t over 74 dt. Solving with a calculator, this will give us the answer of 61.749 cubic feet of unspoiled grain.
Based on the model in Part C, is the amount of unspoiled grain in the silo increasing or decreasing at time t equals 6? Show the work that leads to your answer.
In order to find out whether the amount of unspoiled grain is decreasing or increasing, we need to find the derivative of the volume of unspoiled grain, which is given by the difference of how much grain is being added minus how much grain spoils at a given time. And the given time is t equals 6. So we plug in 6. G of 6, which is given in the table at the beginning of the problem, minus W of 6, which we plug in at 32 times square root of sine of 6 pi over 74, which is equal to 16.06. And we just replace 18.3 minus 16.06. This result will give a positive number, which means that the amount of unspoiled grain in the silo is increasing at time t equals 6.